Hey everyone, welcome back to Learn Computing with Daniel Bullen, with me, Daniel Bullen, where I'm going to be calling all future tech wizards here, where I'm going to be asking one crucial question. Are you ready to unlock the secrets of the AQA A-Level Computer Science theory paper? So join me, Daniel Bullen, on a journey through the depths of this paper as we unravel complex concepts, decode tricky questions, and arm you with the knowledge to ace those exams, and in the case as is an A-level paper, get that university place. So whether you're seasoned at computer science or just started straight out on the A-level for the very first time without doing the GCSE, which is common really, this video is still going to be your passport to freedom, your passport to university, your passport to ultimate success. So before I do, hit that like and subscribe button, hit the notifications bell, share this video far and wide, and grab that virtual notebook. Let's embark on this epic adventure together, me and you, the viewer. So let's dive right in. So the paper 2, it's 2.5 hours, and yes, phew, you're going to need a calculator, which is nice. I'm not going to go through the instructions because that's what an invigilator does just before you start. So I'm not going to go through all the la-di-da. So let's get straight into it. Question 1. You've got a bitmap image of 1,000 pixels by 800 pixels high. The image takes 400 kilobytes of storage space when represented as a bitmap, excluding metadata. So we need to calculate the maximum number of different colors that could appear in the image. So we've got to show our working. Yes, it's 3 marks, so yeah, we gotta show it. Okay? So let's say I want to show our working here. So how we could do it? So we could do, so you would need 400 times 1,000, and that's going to be divided by, so 400 times 1,000. So yes, you can have a calculator for this. If you don't use a calculator when you are allowed to use it, you're just being a plonker. So I'm using my calculator on my phone right now, but you're not allowed to bring phones in. 400 times 1,000, 400,000. Okay? Then we need 1,000 times 800. 800,000. So we've got that. So what we need now is 4,000, 400,000 divided by 800,000. That's going to give us 0.5. That will give us 0.5. So we've got that. So we've got that bit. Then we need 0.5 times 8. That's going to give us a 4. And then what? So we've got that. So that's a 4. So I've literally broken this down. So I've basically got 400 times 1,000 is 400,000. 1,000 times 800 is 800,000. 4,000 divided by 800,000. That's 0.5. 0.5 times 8. That is going to give us a 4. Nice and easy there. So 2. So we're going to have 2 to the power of 4. So 2 times 4 times 4. Yeah, 2 times 2 is 4. Times 2 is 8. Times 2 is 16. So you can have 4 times 2 is 8. But as with colour, we're dealing with hexadecimals. So we're dealing with hexadecimals. So you could do 8 times 2, which is giving us 16. Or you could have 2 to the power of 4. Obviously, you would write it in exponentation form. So we got 400. So we got 400,000, 800,000. So that's one way we could do it. Or we could do 400 times 1,000, 400,000. And then we could have, and then what we will need is dividing by, or we could also have 3,200,000 . So that would be the method that I would use personally. So that would be the method I would have. And just put 8, have an 8 there. And 8 times 2, that's going to give us 16. Yeah, so this would be my method of working. Might be basic, but it's a method that works. I think that works nonetheless. Okay. Let's delete that. And move on. The same image can also be represented using vector graphics. So the vector graphics representation takes an image of up to 2 kilobytes of storage space. So we need to explain why the amount of storage taken up by the vector graphics representation of the image is significantly smaller than the space taken up by bitmap representation. So that's another 3 marker. So bitmap images, they store the color of each pixel. And then bitmap images have lots of pixels. We have lots of pixels. So that is what I would say there. That would be 2 marks. Then I would talk about vector graphics. Store information of the objects that an image is composed of. But they will allow, however, shapes for object, but they will not have equations for object, nor will they allow instructions. So they will, if you said shapes, they'll allow it. If you say equations or instructions for object, they're not going to have it. Okay? And you could also say that large images can be composed of few objects. There'll be fewer objects than there'll be pixels. A single object might be equivalent to many pixels. So that's quite a few answers you could have. Okay? So with theory, it's copy and paste the mark scheme. Let's move on. We need to state one advantage of vector graphics compared to bitmap graphics. That is that fewer bits are used to represent an image. So we need to state 2 other advantages of vector graphics. So, advantage 1. So, advantage 1 would be individual objects can be manipulated. That's one advantage. Another one you could have is the parts of the image can be enlarged without losing quality, or without the loss of quality. Those 2 points, 2 marks, bosh. There you go. So bosh, as a wise man once said, and I will tell you that wise man at the end of the video. So stick with me if you want to know who the wise man is. Question 2. Need to describe what a thin client computing is and explain 2 reasons why a thin client system might be chosen in preference to a thick client system. So that's another 3 marker. So the way I would answer that would be, so thin client computing is processing is carried out on an application server. They will accept your server, so that would be 1 point. That's 1 mark. Done. Why? Because clients are cheaper to purchase. That's your second one. And for the third one, I would say less configuration of clients is necessary. So those, just saying those, that's 3 marks in the bag. You could have others like licensing can be cheaper, impossible to install unauthorized software on workstations, which means it's more secure as fewer settings can be changed. Any of those, that would get you marks. Bosh, there you go. But literally, theory is just dead easy, because what they'll do is they'll ask you the same question, but just copy and paste the mark scheme. Next one. Data communication system can transmit 4 different signals. Each signal represents 2 bits of data. So you need to describe the exact relationship between the bit rate and the baud rate for this system. So the bit rate is double the baud rate. That's all you need to say. That's literally it. 1 mark in the back. Okay, let's go on to the next question. Describe the relationship between the bit rate of the system and the bandwidth of the transmission medium that the data is transmitted through. So they're both proportional. They are proportional. Or you could say they're directly proportional. That's literally it. So just say they're directly proportional, or you could say the greater the bandwidth, or you could say the greater the bandwidth, the higher the bit rate. Any of those will get you a mark. If you say bandwidth constraints bit rate, not having it. And that is question 3. Right there. Okay, here's serial transmission. So, the system uses serial transmission, and 2 marks. For 2 marks, we need to describe the difference between the operation of serial and parallel commission. So if something's done serially, it means sending 1 bit at a time. That's 1 mark. Whereas, to get the second, parallel sends multiple bits at the same time. That's all you need to say for 2 marks. If you say both sides for serial or both sides for parallel, you're only going to get 1 mark because it wants serial and parallel transmission. You could also have serial uses a single wire, whereas parallel uses multiple wires. One of those points, if you just say this Or this, 2 marks. 2 marks, bosh. Right, let's go to the next one. Ooh, ooh. One of the questions they gotta ask, which is why you should be able. Which is why when I tutor students, this is one of the first topics I try to do, along with the mathematical stuff. This is a question you need to make sure you know because it's a question that AQA have got to ask. If you can get this right, you're laughing. But anyway, you've got figure 1, so you've got x0, x1, x2. They're your inputs. And then your output, you're going from Q0 all the way to Q7. So what we need to do is write a Boolean expression for this one. So that would get you 1 mark. So all you need, so you can have Q1, that's the start, is going to be not x2, that's because I don't know how to do this in PDF, so I'm just going to say not x2 and not x1 and x0. So if you remember, if you see a dot, there's an and. Okay, so you're and or not. If you see a line over, that's a not. If you see a dot, that is an and. And if you see a plus is an or. So a dot is an and, plus is an or, a line above a word, a number is a not. So be not x2 and not x1 and x0. That is the Boolean expression. You've got all of these, because all these are AND gates, and you've got NOT gates here, which is why it's not x2, and it's not x1, but it is x0. Okay, now what we need to do in here is complete a truth table for the circuit in figure 1. So this will require us to look back at that circuit. So Q0, as it's going to be a 1, 1, 0, 0, 0, 0. Seven noughts there. That's for the first one. Second one, 0, 1, 0, 0, 0, 0. Yep, 1, 7 noughts. Then for the third one, it's going to be 0, 0, 1. 1, 2, 3, 4, 5 noughts. So the pattern going on here is just going to be all those noughts there. So the idea is for this one, it's going to be all the noughts, and then once we get to the 1, Q7 is going to have a 1. So if we answer it like this, that will get us all 3 marks. So if 8 rows are completed correctly, you get all the marks. If you only have 4 rows completed correctly, then that's going to be 2 marks. 1 row, you're just going to get 1 mark. So that is how we would do that truth table. Obviously, you'll actually do it in the boxes, but I've just done it like this just to show you. Okay, part 3. So explain the purpose of the circuit. So we're basically saying, well, why is it there? So considering the inputs and outputs of the circuit and consulting your answers in that truth table, and the question to 4.1, the Boolean expression, they may help you to do this. So we need to use that information we've got to answer that question. So I would say the output is activated when the binary pattern input is the value n. So that is what you could have there for 2 marks. So it's a 1, which means on. Is 1, which means activated when the binary pattern input is the value n. So that is what I would say, and that is what will get you 2 marks. They will accept n for qn, so don't worry about that. Or you could have relationship between n and output qn, described in the example. If the 5 the input is 0, then the output 0 is on. If the value of input is 1 and 1 is on, and so on. Or they will accept it's a 3-bit binary decoder. Okay? So that is 2 marks right there. Okay, so this is the same circuit that we've done before. Same circuit we've done before to help you answer 4.4. So what we need to do, we've got a logic circuit in figure 2. We'll produce an output S that's equivalent to one of the outputs in figure 1. The inputs x0, x1, x2. So which output, Q0 to Q7 from figure 1, is the output S in the circuit figure 2? So if we have a look at this logic circuit, we've got 2 OR gates and a NOT gate. For it to go back up, so we know it's not going to be x2 and it's not going to be x1. So it's actually going to be, right, so we know it's going to be Q0. So if we have a look, 0 from the NOT gate, it's gone straight to the Q0. They won't have 0, so in this one you would have to say Q0 as the output. Oh. So in here you could just say Q0, and that's it. So that is worth 7 marks. 7 marks, if you get this right, the procedural mastery right, you're 7 marks on the way to a good grade. Okay, let's try the next one. This one is a very long-winded brief. And this is about databases. So you've got a sports center, these are a relational database to store information about facilities, like a swimming pool, and the bookings that have been made to use them. So some of you might have done booking systems as part of your NEA database system. Yes, database system. One of the best things to do in an NEA. Not 2,000 lines of gaming code that is 35% done. But hey. So figure 3, we've got the structure of the relations in database. Facility, sport, booking, customer. They're your entities. And in those are also your attributes. So the faculty relation stores different facilities available at sports center. Facility for sport facilitates what facilities are suitable for what sports. Then booking is all the bookings that have been made. And it has to start and end either on the hour, quarter past, half past, or quarter to the hour. And the customer relation has all the customer details. So the entity identifier, that's the primary key for the booking relation, is composite entity identifier consisting of 3 attributes. We have got an alternative identifier. So we've got the alternative identity identifier that could be chosen, composed of different attributes. So we need to shade one lozenge to indicate which of the following groups of attributes will form a valid alternative entity identifier for the booking relation. Okay. So it would be, if you shade more than one lozenge, then you're just being a plonker. So only shade one. If you shade any more, you're not going to get a mark. You're going to lose 1 mark for being a plonker, which can mean the difference between an A and a B, or a B and a C. If you say facility ID, booking date, end time, that will give you the correct mark. That is the correct one. Okay, so you just shake that lozenge. That's correct. Bosh. Moving on. So we got a different design originally proposed for the database. So this design didn't have a customer relation and had the following design for the booking relation. So we got in booking, we got facility ID, booking date, start time, end time, full name, surname, email address. So we need to explain why this alternative design would have been rejected in favor of the design back in figure 3. So if we go up to figure 3, that is the favored one. And that's favored over this one. And the reason being is because the design is not normalized. So it's not normalized. That'll get you 1 mark. Another mark would be if a customer made more than one booking, then their details would need to be entered more than once. So that we're duplicating the data. So it's data duplication there. So points like that, 2 marks. Bosh. Bosh, no problem. Right, on to the next one. Now we need to complete the following SQL statement. Yes, SQL, you might have done this in the NEA. If you have, you'll be saying bosh at the end of this. So complete the following SQL statement to complete the facility relations specified in figure 3, including the primary key. So create table facility. Common sense would say facility ID int primary key, comma. That is how I would write it. And then description, varchar, that's one of the data types, 100, comma. Unless you put a comma at the end of every line, except for the last one, your code's not going to work because you're designed to be a plonker. Then max people, so maximum number that we can have, and that's going to be an integer, comma. And then we're going to have price per hour, small money, which I would have said currency. So code like that will get you 3 marks. Okay, so just for saying facility ID and identifying as a primary key, that would get you 1 mark. 2 fields other than the primary key, that's another one. Fully correct definition and SQL being syntactically correct, including the commas, that would get you a 3rd mark. If you're being a bit dopey and spending too much time on FIFA or Fortnite or anything like that, and you forget to put a comma and you forget to do commas, that's why you've lost out on a mark, because you've been a plonker on Fortnite or FIFA. But hey, I'm not bashing the games. I'm just bashing the fact that some people would rather do that than actually get on with what they should be doing, like practicing this past paper. But if you get the code, but in a nutshell, facility ID, primary key, 1 mark. Two more attributes, 1 mark. Commas, syntactically correct, no syntax errors, 3 marks, bosh, done. There you go. Next. Right, we're repeating figure 3. So in this context, a customer wants to book a facility. that is suitable for playing basketball on the 15th of June 2021 between 2:15 and 4:15. Wow, 2 hours. So a customer wants to book the facility suitable for playing basketball then. So as part of the booking process, a query is needed to list all the existing bookings that would overlap with the new booking. So we're going to write a query that will list all the bookings for facilities suitable for playing basketball and which would overlap with the booking that the customer wants to make. So for each booking, which would overlap with the new booking, only facility ID, start time, end time fields should be listed. So 7 marks. So that's a big meat and potatoes one. So if I was doing a query, I would be doing start time less than or equal to 14:15, that's the time, using the AND logical operator, and end time greater than or equal to 16:15. So that would be 1. So we would need that for the start time. So those are the conditions that you would need. Okay. So that will start before, existing book starts before then and ends after. So you will get 2 of the 3 marks for correct conditions if they're not joined by the correct logical operators. As we got the correct logical operators, we got 3. And then what we're going to need is obviously need to start a query, we need to select facility for sport, and we're going to use the dot, which is the join. So it's facility ID, start time, end time. And we're going to take it from facility for sport, and we're going to take it from booking. Then we're going to have where sport is equal to basketball. Okay. Then we're going to have and booking. So this is where you need facility ID equals facility for sport facility ID. Then we're going to have and booking date is going to be the 15th of June 2021. And this is where we get into the start time. And then we can have or start time is greater than or equal to 14:15 and start time is less than or before 16:15. Or we could have end time is greater than or equal to 2:15 and end time less than or equal to 16:15. And that is our condition, all the conditions with the where clauses. We can do conditions with inner joins or a nested solution. So we could, if we wanted to, either do this solution, or we could have a nested solution in there, which would look something like this. Yeah. But I'm going to stick with the top solution because that is the one that we don't need an inner join, it's just lots of where clauses. And I would rather the first solution because I've got lots of where clauses and it's easier to code. If you want to do the other two, one of the other two, that's fine, but I personally wouldn't. And that's our question done. Okay, right, assembly language. If you haven't done assembly language before, this is where you need to look at the instruction set and what each of these instruction sets do. And you will get this table. It'd be good if you could memorize it, but if you can't, at least you'll have a table that looks like this, telling you what each of the standard AQA assembly language instruction sets are and what they do. So don't fret too much. But if you memorize it, kushti, better. So label is placed in the code by writing an identifier followed by a colon. So we've got to refer to the label. The identifier on the label is placed after the branch instruction. So to give you an example, operand 2, you can interpret that with an A or a capital R. If you see the hash, using decimal value specified after a number. RM is a value stored in a register. So R6 is stored in register 6. Let's look at figure 4. So we've got an assembly language program written using the AQA assembly language instruction set, as we've explained in table 1 back on the previous page. So the program takes the inputs from the registers R1 and R2 and stores its output in registers R0, R1. So what we've got to do is complete the table to show the results of executing the program in figure 4, where the initial values in the registers R1 and R2 are 34 and 6. So R1 and R2 are done for us. So yes, we are going to need all of this. You don't need to use all the rows. So R0, first one is going to be a 0. And then we go into R3, which is going to be a 1. And then you'll see 110. So that's going to be 1100, which is going to be a 12. And then here you're going to see a 10, which is actually going to be a 2 in denary. And then what you're going to see here is 11000, 24. So what's going on here is it is doubling every single time. So that is doubling. And then if we decide to do 1, 1, 1, 2, 3, 4, 48. So that has doubled. And if we did 1000, that is 8, which is a full byte. So those 2 bits here, that would get you 2 marks. So you would need to go back and forth in between the code. So R0 is loaded. So correct initial values need to be loaded into R0 and R3. So they're loaded. And then we need logical shifting left of the register in the loop. So that's area 2. So we're going in the loop, moving left. So that's the main loop, that's doing the left shift. Okay, and then move left. It's staying in the move left, and this then goes into the main loop, which is the 3rd block of code. Okay? Which is why we've got the numbers that we've got. So it's trying to get more zeros left shiftwards, which is why the numbers are timesing by 2 each time. Once we've reached that, the 3rd block is it might skip, meaning it goes back down. As it's going right, it's dividing, which means R3 is also going to divide as well. So before you know it, we're back onto 100, which is your 4. And then 1010, that's your 10. And then we go into R4, that's R0. And then once we've done that, we'll go back into R2, it's 1100, that's your 12. In R3, that's your 10. R4, that's R0. Okay. And 1, 1 is going to run 1, 1, 0. That's our 6. 1, 0 is 1. And then we don't have an R there. So we'll have 101, which is your 5. And 1, 0, 0, that's your 4 in R1. And then R2, nothing there, nothing there in R3. So we are left with a 1, which is a 1. And in R3, we will be left with a 0. So we did the correct initial values in R0 and R3. We did the logical shifting. And then we exited the loop and then shifted. Once we've exited the loop, we shifted right, which is why we've got 1, 1, 0, 0, 0, and then 1, 0, 0. And then we did the first addition of R0 and R3, and subtraction obviously. And then we did the addition and subtraction loop. And then we did the correct final values for R0 and R1. So something like that would get you 6 marks. Okay? So that is quite a hard question which you need to decompose for this one. Okay, so question 6, part 2. So the initial values for the program are stored in R1 and R2, and the final is stored in R0, R1, R being the outputs. So by considering the inputs and the outputs in that trace table, we need to describe the purpose of the program. So the purpose is that it performs integer division and outputs the remainder. So if we were to say that would get us 2 marks. So it performs integer division and outputs the remainder. Nice and easy. Let's try question 7. So we need to explain why a laser printer with a built-in wireless network adapter is likely to be a suitable choice of a printer for a small office. So, 1 mark for saying why a laser printer is suitable is because it's low cost per printed page. That's 1 mark. And you can have it also prints many pages per minute, so it's high speed. And why having a wireless adapter suitable is because it's easy to share a printer between many devices. Any of those 3 would get you 3 marks. You could also have, however, options to install a greater variety of paper trays, high resolution output, or you can have no need to install a network, printer can be managed remotely, Wi-Fi can be fast enough for a likely number of users, Wi-Fi should have sufficient range of devices to connect. So any of those would have also got you 3 marks, but you only need to mention 3 points, obviously. Okay? Okay, 6 marks. So this one is a big one. So we need to describe the principles of a laser printer. Okay, so we are describing the principles of a laser printer. So you can have bitmap of an image has the built-in memory from the page description. So there is a negative charge applied to the photosensitive drum in which the laser beam is directed at. The mirror is used to direct the laser beam. So whereby the laser strikes the drum, the charge is neutralized, and the negative charge is applied to the toner. The toner sticks to the drum based on the charge. Paper is passed over the drum and the toner transfers to it. So these are some of the indicated points. So the more of these indicated points you would have would get you 6 marks, or closer to 6 marks. So all I've got is some description on how a laser printer works, showing a good level of understanding, key parts of the indicative content covered, but there's gaps. To get 6 marks, you will need to cover almost all of the indicative content with a comprehensive description on how it works. So I've got most of it at the moment, so that would be 3 or 4 marks. So I'm trying to mention all of the indicative content, which means it gets you close to the 6 marks. So the more of this you can mention, the better. So my advice would be, when you're doing a past paper, ask your teacher to mark it. Okay, here's a question that they got to ask. Using binary addition in 8 bits 2's complement, we need to perform the following subtraction. 18 minus 72. So we need to think 18 in binary is 0, 0, 0, 1, 0, 0, 1, 0. Minus 72, this is going to be signed. 1, 0, 1, 1, 1, 0, 0, 0. So what we need to do is we need to take those away. So what's 18? So we would do 0, 0, 0, 1, 0, 0, 1, 0. Take away 1, 0, 1, 1, 1, 0, 0, 0. So using the rules of binary addition. So I go from right to left, like in a column. So 0 and 0 is 0. So 0 and 1, that's a 1. That'll be a 1. That'll be a 0. That'll be a 0. That'll be a 1. That'll be a 0, 1, 0. So in some of this, you would have to do the carries. So if you can represent 18 minus 72, that would get you 1 mark, if you represent that correctly. Where you get the extra mark is the correct answer. Even if you get this wrong, you'll still get 1 mark, even if you get the answer wrong, but the procedure right. So the procedure for doing 2's complement is, I do convert a positive number into binary, flip the bits, add 1. That is what I would do if I was doing this. Convert the positive bits into binary, flip the bits, add 1, bosh, done. Okay, so that's how I would approach it. And that'll be 2 marks there. Right, question 9, this is a big one now. So big data is an important application in modern computer science. So you need to describe what big data is, explain the challenges that big data brings with it, and the approaches that can be taken to overcome these in relation to programming the hardware, and consider some ethical and legal issues that might arise in applications that store data, particularly about people. Yes, people. Important. So what would I do? I would talk about characteristics. So I would say big data is a large database that comes in that cannot be processed using traditional processors or tools. Done. Then I would explain characteristics. So there's a variety of different forms of information, such as email messages, videos, images, and facial recognition, to name a few. Now, so there is a lot of data to process in one data set, which can be as much as hundreds of terabytes. Examples of these data sets can be large medical data sets for diagnosis, gene sequencing, and marketing data. Yes, so big data is used a lot in business now. And then I would also say the data is generated, must be processed very quickly. There's thousands of items to process per second, which means we cannot batch the data to be processed later. Examples of this being used is in card payment fraud detection. So that's one area. We've explained some of the characteristics that big data brings and the approaches that can be overtaken to overcome these. So now we need good understanding. So we know data cannot be stored on one server. So to overcome this, distributed databases provide the ability to break up the data into blocks of individual files distributed across multiple servers. Thereby parallelizing the execution of programs. So you could also have an example function, an example program where we can deal with big data is MapReduce. It's MapReduce. So we can use functional programming to write correct code so we could also have some of the forms of data are unstructured, which can be overcome through machine learning, where we can identify patterns using predictive analysis. Okay, so that's what we got so far. Area 3, we would have ethical and legal issues. So we need to think about the changing laws, particularly in relation to data protection, whereby there are legal requirements where in relation to what data is to be stored and when and how to dispose of that personal data. So examples of laws are GDPR and the Data Protection Act 2018. So people have the right to know what data is stored about them. They also have the right to have their data erased. So the right to be forgotten. So if you can demonstrate that sort of understanding, you will be closer, you'll be close to getting those 12 marks. Okay? So this isn't the sort of question you can say, there we are, bosh. This is the question where you have to put in some time and effort into a question like this. Right, let's go to the next one. So we've got a particular computer uses normalized floating point representation with an 8-bit mantissa and a 4-bit exponent. So you've got 4-bit patterns. They're stored in the computer's memory in figure 5 and they're labeled A to D. So 3 of the bit patterns have floating point numbers and a 1 is not. So we're going to complete table 2 to find the correct letter, A to D. A negative value is valid in representation, that's A. Largest positive value that can be represented in the system, that's going to be D. And the value that's not valid in the representation, because it's not normalized, is a C. So B is the odd one out. And we can't use the same letter more than once. So if you say A, D, and C in that order, bosh, you got the marks. Next one, number 2. So we've got to calculate the decimal number into binary using the 8-bit mantissa and the 4-bit exponent. So if we think about it, we need to do, so we're going to convert this from binary to denary. So work out the exponent. So we know the exponent is going to be 6. So 0, 1, 1, 0, that's going to be 6. Done. Mantissa, that is going to be, so the mantissa you would have to have, you would add all those numbers together. So it'd be 0.5 plus 0.25, etc. Okay? So that would get us, which will get us eventually 0.8125 as our mantissa. And then what we need to do then is we do 0.8125 times 2 to the power of the exponent. So in this case, it's going to be a 6. So, okay, because it's showing that we're doing 6 places to the right. So it's going to be 0.8125 times 2 times 2 times 2 times 2 times 2 times 2. So that should give us an answer of 52. Okay? So it's 2 to the power of 6. So it's that times 2 to the power of 6. So it should be 52.0, as we are dealing with decimals and normalized. So that would get us our 2 marks. Okay. Number 3, in this floating point, the closest possible representation is 104.7. By converting this number back to decimal, it can be seen that the actual number stored is 105. So we have to calculate the absolute error. So it would be, so the way you would do something like that would be 105, take away 104.7. That answer is going to be 0.3. If you do a question, use the information in the numbers, use the information they give you, use those numbers. So I've taken away 104.7 from 105, it's 0.3, bosh, done, 1 mark. This one is where you can say bosh if you get it. Okay, next one, we need to calculate the relative error that has occurred in 104.7. So we need to express our answer as a percentage. So it's going to be 0.3 divided by 104.7, or, so it's 0.3 divided by 104.7. So that is going to give us 0.0029. So let's try it. 0.3 divided by 104.7. It's 0.029. So 0.029 we still accept, but the correct answer is going to be 0.29%. So if you say 0.29%, that's a definite mark. They will accept this though. Well, what I would do is do that and then do the 0.29%, just to make sure you have it. And the last one on question 10 is to explain why the relative error is considered to be more important measure of error than an absolute error. So you could say the impact of an error depends on the size relative to the number that is represented. If you say that point, you are guaranteed to get a mark. Okay? And that answers that on truncation and on the mathematical stuff. So let's go on to question 11. So we've got a computer network. Devices that connect to the network are identified through IP version 4 addresses. When they're assigned, 20 bits have been allocated to the network IDs, and 12 bits have been allocated to the host IDs. So we need the state suitable IP addresses for router A, router 1, router 1 port labeled, and a computer labeled. So you would definitely need 192 and 168. So for the one that's labeled A, it could be between 192 to 207. So let's just say 1.93. And then the Y, 0 to 2.255. So I'm just going to say 0. For B, it's going to be exactly the same. And I'm going to say 65, 0. Then the computer label C, 192, 168 is normal. I'm going to do 1. Or I'm going to do 66. And then here, I'm going to do 2. I'm going to do 2. If it's in the range specified, you will get all 3 marks. If I was to do 255 for the last 79, 2.255 for the last one, that'd be no marks. If I was to do 64, 0, no marks. Which is what I've done. 65, I could even do a 1, which will get me a mark. Okay, so that is that. And point 2. Shade 1 lozenge to see of which of the following four submasks is the one that's been assigned to the device to network configure 8. Process of elimination. It's not going to have 0, 0. It's not going to be 15, 0. It's not going to be 255. So the answer is going to be 255, 255, 240, 0. Bosh. Next one. We need to state one reason why IPv6 has been introduced to replace IPv4. My answer would be it's more efficient routing is possible. Or you could have allows bigger packet sizes. You could have devices can move between location and keep the same IP address. Okay, last one on this one. State the name of the physical topology using subnet mask 192.168.640. It would be a physical star, or star topology, or a star network. But all you need to say is star. If you say star, that's one mark. Anything else, you're just being a plonker and you need to revise network topologies. Okay, 1.5. Laptop computers and other devices can connect to the network via a wireless access point with a wireless connection using CSMA CA protocol with a request send to clear or clear to send. Laptop connected to a wireless access point as data to send to another computer. So we need to explain how the CSMA protocol where RTS will be used during transmission. So it's a 6 marker, so we need a lot of beef in that one. So for a question like that, I'd be saying computer with data listens for the data signal. If a signal is present, then it continues to wait. When there is no data, the signal's present. The computer sends a request to send. And then two computers could start transmitting at the same time if they both detect no data signal. And then the receiver will respond with a clear to send signal. So the RTS signal will block any other transmission from the node in range for a specified time. So when a CTS receive transmits, the computer starts to transmit after the receiver sends CTS. If it's not received, we continue until transmission ends, and then the receiver sends an acknowledgement. And then after transmitting, it'll wait to receive the acknowledgement to confirm that the data is not corrupted. If there's no acknowledgement, then we wait and listen again. And the acknowledgement will notify other computers that they can transmit again, and the waiting periods are often at random. And then the collisions cannot be detected by the transmitter. So the points I've written down and more are indicative content, which the more of it you put in, the more out of 6 marks you will get. Okay, number 12, describe how a MIDI is used to represent digital music. So music represented, it's as a sequence of MIDI messages. and they're usually 2 or 3 bytes long. So examples of music represented, and the first byte of each MIDI message is a status byte. And you can have examples such as data that might be contained in the message, so it could be a channel. And MIDI messages are 2 or 3 bytes long, and the first byte of each message is a status byte. So you can have music represented as a sequence of MIDI messages, and examples of these if data includes a channel. So that would get you 2 marks. Right, number 13, describe the difference between application software and system software. So application software will perform user-oriented tasks, whereas system software is used in the management of computers. Utilities are a type of system software, so we need to describe what utilities are and include an example of utility. So I would say utility software performs non-core tasks, and examples would be disk defragmenter, backup, etc. So I would say software utility. A utility is a software that performs specific management functions of a computer, such as backing up files. That's 1 mark right there. Right, on with question 14. State 1 laws hinge to indicate which of the statements about a computer that uses the stored program concept is false. Process of elimination. The program is stored in the main memory. It's not D, and it's not C, and it's not A, so it's B. The computer can only be used with 1 program, so that one is false. The other 3 are true in relation to stored program concept. Next one, 3 marks. Control unit is an important component of a processor. So we need to describe the role of the control unit. So I would say the control unit manages the fetch, decode, execute cycle. It sends control signals to other components, controls the transfer of data between the registers, and handle interrupts. So I would say it controls the fetching, loading, storing operations to execute some instructions and synchronize operations of the CPU. So that is a type of answer that I would have. Okay. 14.3. One method that can be used to improve performance of a processor is to increase the amount of cache memory. So we need to say what cache memory is, what it's used for, and how increasing it can improve the performance of a processor. So cache memory is a memory that can be accessed very quickly. Memory locate. So that's the first point. Then I would say to store and cache memory will store most frequently used instructions. And the more instructions and data can be stored in the cache, which increases the probability that a particular data item will be required from the main memory. So that is the type of thing I would mention. So I would say a cache is a memory that can be accessed very quickly to store it stores the most frequently used instructions, and this will increase the probability that a particular instruction will be required. So that is how I would do it. And that's all the questions. So we have just gone through the entire 2021 Paper 2 AQA A-Level Computer Science paper. Okay, so that was the whole walkthrough. Remember, practice makes perfect. So what my advice is, grab some past papers. You can grab it on the Physics and Maths Tutors website. Lots of past paper material. And give it a go. If you found this video helpful, don't forget to hit that like and subscribe button. and share it with your fellow coders. Subscribe for more content like this. And as always, oh yeah, before I go, I forgot to tell you the Bosch quote. Yes, for those of you into it, there's a program called The Apprentice. And one of the candidates on there is Thomas Skinner, and he's one who goes Bosch in a Cockney accent, which I'm not going to attempt because I don't want to sound like Dick Van Dyke on a YouTube channel, which I would find embarrassing. Because Dick Van Dyke, worst Cockney accent in history. So I'm not going to try and emulate that. But anyway, if you found this video helpful, hit the like button and the notifications bell, hit that subscribe button, share it with your fellow computer science students, subscribe for more content like this, and as always, good luck.